You ever wonder what really happens in that tiny split second after you click on an icon? I mean, your computer's brain just springs to life, right? But here's the thing, it's not one brain. It's actually more like two. And figuring out how they work together, well, that's the secret to understanding computer memory. So let's demystify the whole thing.
Okay, let's start with a really simple analogy. Picture this. You're at an office, you're all set to get some work done. Now, what's more important for your actual productivity right now? Is it the desk right there in front of you, or that giant filing cabinet over in the corner? Well, the answer is, of course, you need both, right? You need one for the stuff you're actively working on, and the other for storing literally everything else. And guess what? Your computer is exactly the same. Nailing this simple idea is the key to getting your head around all of computer memory.
And here it is. This is our blueprint, our map for today. It's called the computer memory hierarchy. Now, I know, it might look a little complex at first glance, but just think of it like a family tree. I promise, by the end of this, you're going to know exactly who's who and what their specific job is. So at the very highest level, memory is split into two big camps. You've got primary memory, that's your desk. It's super fast to get to, but it's pretty small. It can't hold a ton. And, this is the really important part, it's volatile. Think of it like a desk that gets totally wiped clean at the end of every day. Then you have secondary memory. That's your filing cabinet. Yeah, it's slower to access, but it has a massive capacity. And it's non-volatile. That means it holds onto your files forever, even when you turn the power off. All right, so first up, let's dive into primary memory. This is our desk. Now, if we look back at our family tree here, you can see primary memory splits into two really critical components, RAM and ROM. Now, these two are a team, but they have very different jobs. First, let's talk about RAM. That stands for Random Access Memory. This is the real workspace, the surface of your desk. You know when you're editing a photo, or you've got like 20 browser tabs open? All that active stuff, it's living in RAM. It's basically the computer's scratch pad. It's incredibly fast for reading and writing, but as soon as you shut down the computer, poof, it's all gone, vanishes. And its partner is ROM, which is read-only memory. Now think of this as the computer's permanent, built-in instruction manual. It's non-volatile, so it never forgets. It holds those absolutely essential, unchangeable instructions that the computer needs just to boot up in the first place. You know, it's the code that literally tells it how to wake up and start being a computer. Okay, so that's the desk covered. But where do we keep all our files? You know, our programs, our photos, the permanent stuff? Well, that brings us to the archive. Secondary memory. All right, let's move down our blueprint again. Secondary memory. This is our long-term storage, our digital filing cabinet. And you can see it branches out into three main families: magnetic, optical, and the one you probably know best, solid state. Okay, now let's get into the nitty-gritty. We're going to zoom in on the specific technologies inside this big family tree. So even within RAM itself, there are two key types. First, you have SRAM. This stuff is unbelievably fast, but it's also really expensive. It's used for something called cache memory. Just think of it as a tiny, super exclusive VIP section of the desk, reserved just for the computer's main brain, the CPU, so it can grab its most used tools in an instant. And then there's DRAM. This is the main desk space we've been talking about, the workhorse memory that you can actually buy and add more of to your computer. And that instruction manual ROM, well, it's evolved too. It started out as truly read-only. You couldn't change it. But over time, engineers figured out ways to update it, first with things like UV light, and now electronically. This modern version, called EEPROM, is the reason you can get firmware updates for your router or your TV. Yep, those are basically just updates to its core instruction manual. So back to our filing cabinet. We've got three main ways to store things long-term. First, there's magnetic storage. Think of those spinning platters and old-school hard drives. That was the standard for decades. Then you had optical, you know, CDs and DVDs, which use lasers to read the data. But the modern champion for sure is solid state. Because there are no moving parts, things like SSDs and USB drives are way faster, way more durable, and they're the reason your new laptop boots up in just a few seconds. Okay, so we've met all the different parts, but how do the desk and the filing cabinet actually work together? Let's put it all together and walk through a typical day at the office for your computer. All right, so you click an icon to open an app. What happens? Step 1, your computer goes to the filing cabinet, your SSD or hard drive, and finds all the data for that program. Step 2, it pulls a copy of that data out and loads it onto the desk, your super fast RAM.
Once it's on that desk, the computer's processor can work with it directly, and that's what makes everything feel so snappy and responsive. And then when you finally hit save, a fresh copy of your work gets sent right back to the filing cabinet for permanent safe storage.
So why does any of this actually matter? Well, because understanding this relationship, this dance between fast, temporary memory and slower, permanent storage, that is the key to making smarter decisions about the tech you buy and use every single day. It's the reason a computer can still feel sluggish even if it has a blazing fast processor.
So this leaves you with a very practical question for your next computer upgrade. Do you need a bigger desk? In other words, more RAM so you can juggle more active tasks at the same time? Or do you need a faster filing cabinet, a new SSD, so you can find and open your programs more quickly? The great thing is, now you actually have the knowledge to make that call. Thanks for tuning in.